Okay, I got another 10 minutes here to explain a bit about five. Okay, five. Okay. I tell every second word instead, then it's go twice as fast. That carbonization of thermal energy, it's something that we all need to do something with. And I will tell what Navitec is doing. In Sweden, we have a professor in environmental science, and he say we are in the midst of the largest industrial transition in the world since the Industrial Revolution. What does it mean with this? And it's everyone needs to do something to lower the CO2 impact. And I will come what we are doing with it. Who we are, Navitec, we are active with office in Scandinavia, Switzerland, French market. It's where we today have project and working with the client. We are also on Scotland, starting up there now with Whisky distillery. We are there every third month now and doing some marketing job, visit distillery and so on. For the work, some weeks ago, I won a prize, Impact Award in Sweden. It's the work we are doing in the green transition of the industry client. We are biofuel specialist. In the past, I built a pellets factory in 2005, and that's how I started the company. So we have been working a lot with different type of fuel, biogas, different type of wood, agro residues, and other things. So this is something that we can help our clients with. What we are looking into when we come to an industry client is to see the boiler, the thermal energy flow through the factory. The input to the burner, how is it changing over time? The pot still, when you heat it up, you use a lot of energy for 30 minutes, 40 minutes, 50 minutes. And then when the distillery process starts, it go down and you have a low consumption. How do you build an efficiency system in this way? What we're trying to do is to push these peaks down so we can have a more stable load with higher efficiency system. So we save energy for the customer and also have a better energy system that delivers steam or hot water or what it can be with our CO2 neutral fuel. That's the most important thing. So we go away from oil and gas. And that's absolutely possible to do for all branches today. This shows a module system. This is something that we're working with. This boiler house here can be prefabricated completely in workshop. It can be up to 3 megawatt thermal output from the unit. We can combine more unit to each other to have 6 megawatt, 9 megawatt. That's possible, but it's also to look what is the need for the distillery or what the client have for the production. So we investigate what is the real use, how to save energy, and after that design what design can we use for the industry. And a normal standard system here contains of a pellets burner, boiler, pellet silo you see here, a filter to clean from dust, and the boiler house, of course. And this system is full automatically, start, stop automatically. If you go home over the weekend, it's stop, and when you come on Monday morning, it's a pressurized system, and you can start the production. So, and we have been working with this type of system over 15 years now. I started to develop it, it's around 15 years ago. So we have been delivering a lot of this type of technology. Here is a picture from the workshop. How it looks. To the far right is the combustion equipment where the pellets burn. And it's a fast reaction burner that can react as a boil or gas burner. So we can switch. You see the boiler in the middle, you have feed water tank and other equipment. So it's a complete unit that can be delivered in place. Or we can take a component package, the same, install in an existing building. It's up to the client. Here is a project. In the past, I was working with Thomas Larsson. He's sitting somewhere here. High Coast Distillery. It was a place built to have a good look in the whiskey village. So we installed everything on a skid, lift it in place, and build the building around. So it was a quite fast installation. And it had been working in, I think, close to 5 years now. It's on reference. It's absolutely possible to go and look there. Thomas will gladly help about this. Another distillery in Sweden is Tevsjö, to the right. It's a smaller unit on 700 kilowatt. High Coast Distillery, it's approx 1 megawatt unit. You see there. Oh, I can also tell that High Coast Distillery, what have they done for the environment? How much have they reduced in CO2? If we compare to something that everyone knows, a car, if you drive 10 kilometers, you let out some CO2. The amount of oil we reduce in this project, if we compare this with car, it's 10 million kilometers per year have been reduced within this project. So it's quite much. 10 million car kilometers. And today people speak a lot about how to remove diesel car, gasoline, and have electric car. But this type of project have really high impact on the decarbonization. Another one we did in Sweden, it's also module-based, also possible to visit. Smashed tomatoes, ketchup. If we go up in bigger size, it's also possible. This is 10 megawatt, another project in the south parts of Sweden. They produce oat milk here. It's some place build installation with another type of burner equipment at the top. So it's absolutely possible to scale up if you want to decarbonize, not only these smaller units. What is the key to a successful project? Long experience and expertise. This is something that we have in Navitec. We are close to 40, 45 people today. A lot of engineers with a long experience. We have done this for 20 years in Sweden now to decarbonate industry and a lot of things. Another thing you see here, we can send out this presentation after. I need to speed up a bit like Jan told me. This is also what we are. We are a company group. One interesting thing I can end with, biochar is one business unit we have. We are now together with Thomas looking into how to dry spent grain. It can be possible to put it in a reactor, produce biochar, take out the methane gases, burn the methane gases, and it go into the production. And then do good things with a waste that cost money to get rid of. This is a project that we are starting now to look into. It's also one big topic in French market. It's to go from wood pellets to agriculture pellets in the combustion. So it's not something we start up with Adam. It's a support apartment in French market to if here you want to switch from fossil fuel to fossil-free fuel, it can be, you can have some grants around 50% for the equipment. Yeah, and that's who we are. So if you have any more question about decarbonization, yeah, speak with me. Thomas is here also, helping Jan, so then we can try to catch up. And
thanks very much, Nicholas. All right, we're going to crack on with our second session. Embracing change, planning your resources. So we're going to look at peat, we're going to look at malt, and we're going to be looking at oak as well. And we're going to be kicking off with Dr. Barry Harrison. He's a biochemist, PhD from Heriot Watt, and it was on whisky. On peat itself. Eh? He is Mr. Peat, you know. So yeah, looking at the I remember reading the paper. It's amazing. Like peat terroir is fascinating. And he was based at that Swirry Scotch Whisky Research Institute, where he still works, leading various teams and helping the industry, providing the industry with scientific knowledge to surmount challenges such as reducing emissions and water use, and controlling flavour, maintaining flavour diversity, while making changes to raw materials and processes. If you want to know about peat and smoke, this is your man. Barry, over to you.
Thank you. Yeah, so the first thing you asked me to talk about was who the Scotch Whisky Research Institute are. I explained to a few people over the last day or two, but for everyone else, here's the formal introduction, and that's our mission statement there at the top. But we're the research and technology organisation for the Scotch whisky research industry. So we're owned by the industry. The industry will put money into our research and fund and plan what we do. Account for the majority of the industry, but maybe about 90%, I think, goes from sort of the bigger players, the Diageo, the Chivas brothers, all the way down to smaller companies like Holyrood or Scotch Malt Whisky Society. So a fairly broad range of companies that we're working for and working with. We've been around since 1974 in one form or another in Edinburgh. Moved to where we are now. There's a wee picture there. It actually looks a wee bit like a distillery as opposed to the last place we were in the centre of town, which had one of the instruments was in a toilet. I think it just clearly wasn't purpose built for what we were wanting to do. But we've obviously got the place now. And a lot of scientists, chemists or biologists or biochemists or a mix thereof at SWRI. We have labs. We do. We cover the whole process from the raw materials, from the grain, the yeast, the water, the peat, through the process. So that's kind of my area, from the raw materials through the distillery into the new mixed spirit, and then we've got maturation facilities. We're obviously studying the maturation process as well, the final product, and the final product protection, and making sure there's nothing in there that we don't want there to be in there, and also looking at authenticity as well, and making sure we can identify stuff that isn't Scotch. But as I say, my area is mainly raw materials, processing, peat being one of those. We don't work by ourselves. We work with lots of other people. We have our own expertise, but we need to work with a lot of other groups, from universities to other institutes, and even the sort of trade associations, the Scottish Whisky Association, the MAGB, the maltsters. Certainly a key one for peat work would be maltsters. Obviously, we have to go back into the supply chain and work with them if we're going to make any changes to peating process. So first, I thought I'd better just explain peat and why it's important. For anyone that doesn't know what peat is, there's a few definitions, but based around it's kind of wetland that's composed of semi-decomposed organic matter deposited in situ in this particular definition, formed in areas of excess moisture where it rains lots or the rain can't drain away, low average temperature, high acidity, all the conditions you find a lot in Scotland. Depresses microbiological activity, stops it getting fully degraded, so you've got that semi-decomposed, for want of a better term, material. And healthy peatlands, as you may know, are very important. Valuable ecosystems are a valuable resource. 20% of Scotland's landmass are peat, storing around 1,600 million tonnes of carbon, so clearly a good carbon sink when they're working properly. They support lots of biodiversity, lots of plants and animals that are associated with peatlands. They contribute to water quality. They reduce flood risk by not letting all the water just flood off too quickly when they're healthy, which is a key point because roughly 80% of peatlands in Scotland are not healthy. They're degraded to one extent or another, and this is down to drainage for one reason or another, whether that's construction, agriculture, different purposes, peat extraction obviously as well for use in horticulture, heating, as well as for making peated malt for whiskey. And so, yeah, once it's degraded, it's emitting carbon, it's contributing to climate change, it's not good, it's a liability. But why is this important for Scotland? Obviously, we're conscious in using peat, it's a valuable resource, but why are we using it for making Scotch whiskey? Yeah, it's an important flavour for a lot of Scotch whiskey, be that blends or malts, which you'll be familiar with. It's embedded in what Scotch whiskey is. It's introduced during the malt kilning. For anyone who's not aware, that was one thing I was instructed to remind people, because there are people, and people who you think would probably know better, that think that peated water gives peat smoke flavour. That's definitely not the case. It's from smoking the malt during kilning, given that characteristic peat reek to the malt. So yeah, we're not a big user of peat in the grand scheme of things. In Scotch whisky terms, sort of a wee back of the envelope calculation was about 0.003% of the total mass of peat in Scotland is used for making whisky every year. It's not a lot in sort of gross terms, but no peat use is negligible in terms of impact on the environment, and we're conscious of that. So wanting to use it as responsibly as possible is a key objective for the industry. So coming back to this one, working in collaboration. So I think I had a wee point here that, yeah, working with SWA and MAGB particularly on this, working with partners within the supply chain. We've been working on the commitment to responsible peat use that the SWA have been drawing up with 3 pillars on it. Looking at responsible extraction, how is the peat extracted in the first place for making the peated malt, and we can look at that and try and be a bit more efficient or less destructive in the way the peat's extracted. Rather than having to drain a large area, maybe focus on smaller areas. There's work looking into that, how that can be better carried out. There's optimising the process when you've actually cut the peat, and this is where we come in, the Scottish Whisky Research Institute, which I'll talk about in a wee second. That's kind of the work that we can help with. And then there's peatland restoration. There's a lot of work that the companies themselves, the whisky producers, in collaboration with NGOs and other people who are looking at ways to restore, or projects to restore peatlands, because clearly a lot of it's damaged, and so we want to be improving that situation. So in terms of optimising the process, there's Scottish whisky regulations which we have to bear in mind, have to adhere to. We're quite lucky in the lab. We can we can work within those regulations, but we can also look out with them. You know, if we're thinking what might be possible if they didn't exist, and if you really just wanted to focus on what would make the process as efficient as possible if there was no rules. So we have that opportunity, and then it's a question of trying to balance what is most important, sort of the traditional practice versus the environmental impact. But for any investigation, so for us, we need a fundamental understanding of what makes peat smoke flavor. So a little bit of light chemistry, which is, well, it's kind of a fundamental, and it's what we sort of go to when we're looking at the flavor impacts, and we need to bear this in mind. So phenols, which most people are probably aware of, are kind of the central components of smoke flavor, peat smoke flavor. And you've got 3 different groups, essentially. You've got these ones here, the parahydroxyphenols, so, or just known as phenols. But then when you add these wee groups, the OCH3s and methoxy groups, you go to glycols and then syringols, so slightly bigger ones. These 2, the glycols and the phenols, they make it through the distillation process into the final spirit. These ones are too heavy and just don't make it into new make. And these components are all derived from lignin or other polyphenolics found in plants. As I say, yeah, mentioned that. And so, yeah, in peat, you can have a mix of vegetation. Sphagnum moss tends to be kind of the base material. It's the stuff, the moss, that really holds in the moisture and contributes to peat formation. But you have other different types of vegetation, grasses, heathers, and sometimes trees even. Sphagnum itself doesn't have any true lignin in it. It's made up of mainly these ones, just the phenols. Grass lignin is made up of a mix of all those different units I was talking about. Heather is glycols and syringols, so they're all different in terms of what they're composed of in terms of the different units. And then the partial decomposition in the peat bog mixed with these different vegetation then gives you the specific profile that gives you peat and peat smoke flavor. And yeah, in terms of flavor and flavor impact, just as a wee comparison, you've got, press the right button, glycols up here, which are more of the kind of smoky or sweet or spicy type aromas, whereas the phenols, the non-methoxy ones, more of the medicinal type aromas, which are kind of, or one of the more prominent features of peat smoke, I would say, versus other types of smoke, is more of that medicinal flavor. Yeah, as I was saying there, peat smoke tends to contain more of those types of compounds versus, say, wood smoke, for example, which would have more glycols and or the syringols. Peat flavor is complex, so it's more than just phenols. You know, peat is a highly complex organic mixture to start with, so what you get when you burn it is quite complex. One estimate was up to 1 million compounds. I'm not sure if that's true, but there's a lot you get from peat compared to unpeated versus new make whiskey. The amount of additional compounds you get in there is significant. So there is a potential to add a lot of flavor complexity when using peat, and a lot of that composition just isn't understood, but we continue to work on that. So in terms of optimizing the process, so that's what we've been looking at for our part at SWRI in terms of efficient peat use and helping to use it more responsibly. So you can optimize the current process. You can look at all the process parameters that exist now and try and optimize them and tune them to maximize transfer of congeners from peat into spirit. Another area we're looking at is using peat from different sources. Say you've got an already damaged site or where peat's getting extracted anyway, can you use that to make peated whiskey? And then going a bit more extreme is then what would happen if we could change the process? What would be the best process to give us the best transfer of congeners from peat into the smoke and into the spirit? And finally, if you just can't use peat anymore, or if we're trying to supplement it with something else, is there anything else that could be used in addition? So just a few quick examples of the sort of stuff that we look at in the lab in trying to optimize the process. We've got, for this plot, is looking at the kilning process. So can you adjust the temperature, the airflow, and improve the recovery of the different compounds? So taking a glycol and a phenol, you can see that if you change your temperatures, you get different levels of these compounds, and you can find a point where you'll get a maximum of different compounds. It's slightly different for different compounds. And same with airflow. If you change the airflow going through the heated zone, you'll change the level of compounds coming out. So say, for example, if we turned the airflow right down, that would be very bad news for glycols and phenols. So make sure there's a bit of flow going through to carry it away from the heated zone and not break down too much. Yeah, see that. Airflow. Yeah, airflow probably easier to control in temperature. Kind of slightly conscious of the fact that you're nodding there, Dave, that temperature control in a maltings in a kiln isn't exactly straightforward. You know, in the lab we can type in 550 degrees or whatever it might be, what we want the temperature to be. In the actual kiln, in the real world, that's not the case, and it's more, obviously, much more limited on what you can do. Airflow going through the kiln is something you can apply a bit more control to, and is also a key factor. So there are learnings there to be taken that could be used. So yeah, if we did want to apply such precise controls in a malt kiln, what could we do? It'd be hard to do with the current kiln technology. So this is where we're sort of thinking, what if we've changed the process? What would be the best way to do it? And one way would potentially be more akin to what they do for making liquid smoke commercially for flavoring. So where you can pyrolyze, that's burning without any air in your combustion zone, or your heating zone, sorry. And you know, there's an already established process for, whoops, keep pressing the wrong one, for taking the, well, it would be peat through a process and getting your condensed smoke. So you could make a liquid smoke, potentially a condensed smoke, I should say. That might be a way to apply more in this pyrolysis process. They can apply a bit more temperature control in there. And so that might be one way to improve the process if we were going to make a change. Doing trials in the lab where we've tried a similar sort of thing on a small scale, you can see relative to real or traditional practice, you can get sort of, say, 5-fold increase in the level of glycol in our initial tests. That didn't work quite so well for the phenol in this test, but a bit of tweaking of the process might improve that. But certainly the potential is there from looking at just that one. You can get a lot more from changing that process and adding that control. The challenge would be you'd have to change potentially legislation, particularly if you were condensing smoke and adding that to the malt. So, as I say, consider the environmental benefits alongside preserving the traditional practice. The other, as I say, the other area we're looking at is looking at peat from different sources. So, if we can identify places where the peat is coming out of the ground anyway, can we utilize that? So, where we've looked at that is construction projects. So, for example, for renewable energy supply, people are building substations and these sort of things, and inevitably, because of where the supply is coming from, they're going to hit peat lands at some point. You know, this is the coverage of peat, all these different coloured bits around Scotland, and this is where construction projects are taking place by one particular company, and some of these are just going to overlap inevitably with peat. You just can't avoid it completely. So where that it does happen, it is as much as possible reinstated on site, but I think that can be a challenge. You know, within the regulations, they're supposed to put it back as a functioning bog, and I don't know how feasible that is really. So the opportunity for them to provide peat to make whiskey, they were quite keen when it was suggested. For example, we're looking at one project, a construction project where it's maybe 100,000 tons of peat that they were having to take out the ground for their substation, whereas we're using about 8,000 to 9,000 tons of peat per year for making whiskey. So there's a lot of peat there. Could it be used for making scotch? But in looking at this, we do have to bear in mind that the peat you use, it can affect what you get as an end result. The peat source matters. We've seen this where we've taken samples of peat from all across the supply chain, from all the different sites that supply Scotch whisky, looked at the total phenol levels, and you can see quite a big range going from 300 ppm all the way down to 10 or something. You know, orders of magnitude difference in terms of how much phenols are. A lot of that's obviously down to how much moisture's in the peat. Some of it's very wet when it comes to the maltster, some of it's much drier. But even within that, there's still a lot of variation from peat to peat. So there's that. There's also the fact that, going back to my PhD days, my project there, having a look at peat from different sources, I found that matters as well in terms of the relative proportions of different phenols. So you've got, what this plot shows is, if you kind of look at them simultaneously, the new mixed spirit made from Tomatul peat up here has got a relative high level of phenols and a relatively high level of medicinal aroma, whereas the new mix down here, made from these peats, has got more of the glycols and more smoky aroma. So, you know, what I found was the peat you use has an effect on the flavour. So do have to bear that in mind when taking peat from any new source. So that's what we're looking at. We're looking at a site doing trials from the construction site, lab trials to test out the smoke against current extraction sites. That seemed quite promising. So at the minute, there's full-scale trials looking at more of the practicalities and the logistics of taking peat, because it's not necessarily straightforward. For one thing, getting it dry is one thing we've been finding is a bit of a challenge, because we can't dictate when they're going to go and take all the peat out of the ground for their construction project. So if that's later in the year, then it's very difficult to get that dried to a suitable level. Having said that, there's quite a variation in the levels that do seem to appear. And the other thing is the sort of intermittent availability of peat. If you're looking at displaced peat, because these projects will happen like once a year or something like that, or maybe not even that. Yes, you get a lot of peat, but it's not a consistent supply. So one example of what you could do maybe is condense the smoke from that peat using the sort of the pyrolysis process we're talking about, and then store that liquid smoke as a potential solution. Just an idea, but again, pushing the boundaries there. I thought I better mention AI at some point. I said, if this is a science, anything science related, I do need to say AI at some point in the presentation. So I've squished it in here. If we are using peat from different sources, a nice rapid analysis method would be useful. So predicting phenols levels and the flavor of peat just by looking at the peat itself would be very handy. So yeah, we've been doing tests on that using specifically hyperspectral imaging and artificial intelligence to do lots of taking images and then doing lots of maths and getting results which can correlate peat composition with what you're going to get in the final spirit, which is quite cool. And yeah, the final thing was supplement peat with another material. Is that possible? Is there anything else out there which can give you the same flavour? From what we've seen so far, if you really want to make peat flavour, it's likely that the things that are going into the peat bog, things like the moss or the heather, are going to be the closest matches. But I put a wee picture here just to demonstrate the issue with sphagnum moss specifically. It's very, very wet. I mean, that's its whole function in the peat bogs, to hold water. So trying to get that dried down to burn it would be the first barrier. But in terms of flavour, I mean, logically, they're the closest that we've seen. If you look at wood smoke, for example, it tends to, I think, as I said, have too much in the way of glycols, so there's methoxy, the more spicy, smoky flavours versus the medicinal phenols. So peated oak or unpeated oak casks, if you burn them, you get more glycol versus phenol, whereas the peats, any peat, you'll always get more phenols, and that's kind of a fundamental difference if you're trying to use wood instead of peat. Of course, one question on that is, could you burn it differently if you had the option to change the temperature, turn it up a bit and reduce the relative level of glycols? Could you then balance out a wee bit and make wood smoke into peat smoke? More left field ideas. We've had a few coming through. Spent coffee grounds is one. We've been working with Heriot Watt Uni and some students over there. Yes, it's an abundant byproduct from making coffee. But would it be viable for use in smoking malt for smoked? Well, it wouldn't be peated, but it would be smoked at least. Whisky. And this is kind of sensory analysis, quantitative, on the different attributes that we look at. I'm going to keep pressing that button. Burnt, smoky, medicinal, overall peat intensity. It doesn't look too different, but the key thing was the burnt aroma for this is the coffee grounds, this darker coloured one. And it was a very distinctive burnt note, is what I would say, kind of like burnt coffee, basically. Yeah, which is maybe didn't come out as a huge surprise. So peat's a key part of Scotch whisky flavour. Responsible use is a key focus for us. And we can look at it in terms of making incremental increases in efficiency or improvements within the definition, selecting the right peats, controlling the combustion process. But then step changes certainly could be possible, might require more looking into legislation and justification. But for our part, the SWRI, we're here to look at all these different possibilities and how they could help our members and supply chain make informed decisions. And speaking of AI, I did think I'd ask AI to make a wee image of what the future of peat killing should look like. I don't know what this is all about, but it's got a nice wee control panel and a couple of Henry Hoovers in there to clean up after. But yeah, a bit of work on the AI there, I think. Oh, actually, no, sorry. There's another couple of slides. I was asked to sneak in a wee plug for the Worldwide Distilled Spirits Conference by my colleague who's organising it, which is next year. And if there's people interested in science and technology of whisky production, that's a good place to go. Next year, 4th to 7th of May. Registration open sometime. Thank you.
Thanks very much, Barry. Great stuff. Yeah, coffee grounds smell like burnt coffee. It's an extraordinary insight. Our next speaker is Dr. David Griggs, who's a technical director at Crisp Malt, major malt supplier and provider of high-quality socks. And our main sponsor, our headline sponsor, so once again, from all of us on the World Whisky Forum panel, thanks very much for your support. We wouldn't be here without you. Dave's got an honours degree in industrial biology, PhD in plant biochemistry. Started in the maltings 1990 as a senior research scientist.
There's hair in
Yeah,
those
there
days.
was hair at one point, and that was at Paul's Malt, now Burt Malt, as you probably know. And that he's covered essentially all aspects of malting, all the way from raw materials to brewers and distillers end use. Joined Crisp in 23, and he does everything from technical things to liaison with breeders, new variety evaluation, which we'll touch on, technical projects, quality control, assurance, technical support, sustainability, and educating the next generation of maltsters, brewers, and distillers, and making the tea. So, Dave, over to you.
Dave, thank you for that very kind introduction. I suppose I find time to come to things like this and all the things I seem to have to do. So just a word of warning, there will be sock inspections tomorrow morning. So entry is by crisp sock only in the morning. So it's great to be back at the World Whisky Forum. Thank you again, Dave, for the invite to speak and the opportunity to sponsor as well. So my brief was really to talk a little bit about heritage barley and sustainability. So it took a little bit of while to kind of decide how to weave this all together. So I hope it all makes a degree of sense. So start off with a little bit of a history story. So if we go back in time, go back into the 19th century, malt production was fairly local to the distillery, could even be at the distillery. I assume everybody knows why pagoda roofs are put on distilleries, do they? Well, that's the maltings, not the distillery. So it's interesting that that's persisted, even though distilleries no longer generally don't have maltings. So in those days they were using, I've done the same as Barry, pushed the wrong button. So in those days it was really barley land races. So these were selections which had been made local to the distillery. So we've got examples such as Beer and Scotch Common. Beer is a 6-row barley, which is the growing of which has persisted through to this day, and the kilns were actually fueled by burning peat. So we don't actually fuel our kilns anymore by burning peat. We burn peat separately, as Barry discussed, and then we pipe that smoke through into the kiln. Through the 60s and 70s, there was a big increase in distillery capacity, and a lot of raw barley and a lot of malt moved up from England. There wasn't enough capacity in Scotland, so a lot of movement of malt and barley going north. Into the 60s, Maris Otter was used. I've done it again. Maris Otter was used extensively, and then also Golden Promise. And we'll talk a little bit about these varieties as we move through the presentation. And then we start to see the growing of spring barley in large volumes in Scotland. This really developed alongside the new malting capacity, which went up in the 70s and into the 80s. And then a significant change to the varieties used by the industries occurred in the early 2000s, where the Scotch Whisky Association dictated that only the non-GN barley varieties should be used in the production of distilled spirit. And we'll touch on that as we move through the presentation. So some of the varieties that obviously we can talk about, and ones we've mentioned already, Scotch Common and Beer. We'll talk a little bit about Chevalier. We'll touch on Plumage Archer. So Chevalier was a selection. Plumage Archer was the first hybrid barley, so the first deliberate crossing of two parents in an attempt to make an improvement, which certainly occurred with Plumage Archer. It was used extensively through to the 1960s. And Plumage Archer was a grandparent of Maris Otter, which is a very famous variety. And again, we'll touch on that as we move through the presentation. So these barleys have low spirit yield, and we'll touch on the spirit yield that we might achieve out of this. But what we do find is that they produce interesting new make spirit flavours. And if you combine the varieties with a traditional method of floor maltings, then you can enhance those flavours further. So talking a little bit about Chevalier. So very famous. dates from the 1820s, and it was selected by this gentleman here, Dr. the Reverend John Chevalier, and it was discovered in Suffolk in the UK. So he was a very busy man. He was a doctor, he was a priest, he was an agriculturist, he was a magistrate, and he still found time to have 3 wives and 15 children. So he was prodigious and found this wonderful barley, which this story here is probably slightly apocryphal, but he was going through the garden of one of his cottages and saw this wonderful ear of barley, which he kept for himself, and then slowly started to build up the availability of the barley. I'm sure his tenant didn't see any income from it, but over the years, Chevalier was grown throughout the UK, but also throughout other parts of the world. So it made it onto the continent, it made it into the Americas, and the last significant quantity of Chevalier was grown in Australia in the 1950s. This quote up here comes from a book written in the 1880s by Stopes called Malt and Malting, and he could be describing here a modern barley variety. So he describes it as friable and high percentage of starch and a great weight. So how did we come to resurrect Chevalier? Well, it was through an association with the John Innes Centre in Norwich, which is a globally renowned plant science institute. They were looking to try and find some disease resistance, indeed fusarium head blight resistance in barley. And the group was actually run by 2 people who had their own craft brewery. So they had a little bit of knowledge of Chevalier, and they approached us and said, would we be interested in re-commercialising Chevalier? And the interesting thing is they found the resistance to the disease they were looking for in Chevalier. So that might go some way to explaining its longevity through the Victorian era and into the early 1900s. So we started working with Chevalier in about 2010, and we started just with 5 seeds from a seed bank, and over the years we expanded the amount of material that was available, and now we're harvesting about 300 tonnes of Chevalier a year. It's not an easy crop to grow. When we brought it through to commercial stage, obviously there was no one alive that had grown it. There was no one alive that had malted it, and no one alive that had brewed or distilled with it. So it was a voyage of discovery from throughout the supply chain. So we'd worked quite closely with Holyrood Distillery in Edinburgh. This is Callum Ray, the head distiller. They've done a lot of work with these heritage varieties. So this is some quote from Callum. We love using Chevalier because of the uniqueness of flavour and textural properties it gives. Has some quite stark differences from Laureate. So those of you that are familiar with modern malting barleys will know that Laureate is the dominant spring malting barley at the moment across the UK and across other parts of developing a lot across other parts of Europe as well. So a lot of the current distilling malt is made from Laureate. So they're very happy with the flavour of it. They're also liking the textural properties, the oiliness, which can turn to pastiness, sticks to the palate and provides a delightfully long finish to a drink. So they are putting out some product now which has Chevalier within the spirit makeup. And these are some spider diagrams coming out of Holyrood, where they've done sensory analysis, comparing new make spirit from Laureate and comparing it to Chevalier. And you can see there's quite distinct differences in the makeup of the flavour. So Laureate tends to fresh fruit, floral, whereas Chevalier is a little bit more cereally, certainly more sweetness coming through here from Chevalier. And these would have been malted under the same conditions, so we're seeing some evidence here that variety is contributing to flavour. So Maris Otter, world famous. it's a year younger than I am. So this is 60th harvest this year. Looking at the weather, the combines are probably rolling in Norfolk today, and Mamisosa will be one of the first barleys which will be harvested. So introduced into the UK in 65, it remained on the UK recommended list through to 1989. A lot of Mamisosa would have been used in the distilleries through that period. It was bred at the Plant Breeding Institute in Cambridge. It's a winter barley, but its parents, one parent was a spring variety, Proctor, which in itself was a successful malting barley, and the other variety was Pioneer. So this has a winter growth habit, so it will be sown in September, and it will grow across through the winter and come to maturation in late June, early July. And it was very much the mainstay of the UK malting industry through the 60s, 70s and 80s. It nearly faded away, but it was rescued by two grain merchants. There was still support from it from the brewing industry. We have it grown on contract now by specialist malting barley growers. The demand remains, predominantly for brewing, but there are a number of distillers which are using Mamisosa because of the flavour, again, the flavour attributes that come through to new make spirit. This is some work trying to put a little bit of science, perhaps around some of those flavour differences. So this is flagon. So flagon is another winter barley, not used for distilling, but very much used for brewing. Produced on our Saladin malting plant at Great Ryborough. And I think yesterday at Linetti there was discussion around GCMS. Well, this is a GCMS trace, and this is looking at volatile organic compounds associated with this particular malt. And you can see there's a range of peaks appearing on this trace. And we repeated the work with Mamisosa, which had also malted in exactly the same malting plant under exactly the same malting conditions to give malt of almost identical standard malt analysis. And what we find is we see differences in these compounds. So the ones which have been ringed are the more significant differences coming through. Whether these are flavour compounds, we don't know, but clearly there is something different coming through from the variety here, which has been when you process the material in the same fashion. We also continued the work. I don't have a slide, but we continued the work looking at Mamisosa, which had been malted on the floor maltings, and there's a difference again between this slide and the Mamisosa coming off of the floor malting. So there is an element of variety times malting environment which is having an effect on flavour. Another well-renowned malting barley used within the distilling industry is Golden Promise. This is the only barley which was born in a nuclear reactor. So Golden Promise is a product of mutation breeding, which was going on quite a lot in the early 1960s. So it's a gamma ray mutant of a landrace called Maythorpe. Its attributes brought shorter straw, higher yields, early maturity. Early maturity is quite important in Scotland because the weather can change quite quickly into the autumn. So at its peak, nearly 500,000 tonnes of Golden Promise was being produced, and it went through the 70s and the 80s. So major distillers still wanting to use Golden Promise within their production, and ultimately Golden Promise was superseded by a variety which was called Triumph. So what's interesting to consider with these varieties, we mentioned it earlier on, is spirit yield. So this graph looks at that evolution with time. So predicted spirit yield is the measure that we make in the laboratory in terms of evaluation and providing information to the distiller about expectations around the type of yields they may receive in the distillery. So Chevalier Yeah, if we get 330, 350 litres potential, we're doing quite well. That steps up with the breeding, with the production of plumage archer, around 380. With Maris Otter, we might have seen 400. And then as we go through the eras, through the 1980s, through Golden Promise, into Triumph, and then into the modern varieties, Chariot and Optic, we are getting, you know, high levels of spirit yield. One of the main drivers around the introduction of new varieties for distilling is spirit yield. So it's not surprising that we see this improvement over time. I think personally we're hitting a plateau. I don't think this will go up continuously unless we can produce massive grains to do that. So I think if we're hitting 420, 425 litres, then that's probably the potential that we would look to do. Now, people who are down here wanting to use Chevalier Maris Otter, they're not interested in getting 425 litres. They're interested in the flavour, so the quality attributes of the spirit that might come out of these barleys rather than the absolute level of spirit that could be achieved by using one of the more modern introductions. So let's talk again about, let's mention GN. So a little bit of science here. I won't go into the science, but I think everybody's aware that the ultimate result of glycosidic nitrile in a barley variety is ethyl carbamate, which is urethane, which is a known carcinogen. And at each stage of the malting into the distilling process, each stage makes a contribution towards the risk of ethyl carbamate formation. And back in the early 2000s, the decision was taken that varieties which did produce glycosidic nitrile will not be approved as an approved malt, approved barley for distilling malt. So the Malting Barley Committee in the UK will now only approve non-GN producing spring barley varieties. And these varieties are not only those used for pot still or distilling malt, but also those varieties which are high diastatic, which are used in the grain whisky production process as well. So Optic was the last of the GN producing varieties, and we really need to note that all of the older varieties, so Maris Otter, Chevalier, Plumage Archer, Golden Promise, Bear, they're all GN producers. So if you're using those varieties, you need to understand that, and you need to make sure that you are managing the ethyl carbamate production, because although there is only a couple of geographies where there is a maximum ethyl carbamate level in distilled spirits, Canada and Brazil, with a voluntary level in the USA, no one can predict what future legislation looks like, and there is the risk that spirit containing ethyl carbamate may at some point be legislated against, which is the reason why the industry has moved to the non-GN producing varieties. So trying to think now a little bit about what we're all focusing on. So sustainability, top of most agendas these days. Climate change is here. So anyone who lives in the UK will be aware that we do have quite fluctuating weather patterns. However, the last two springs have been complete opposites of each other. So this is spring 2024. So spring is March, April, May, according to the Met Office in the UK. And this map compares the rainfall amount versus the average from 1991 to 2020. The more blue is the more rain. So you can see that last year we had an exceptionally wet spring, particularly affecting the barley growing areas, northeast of Scotland, down into North Yorkshire, down into East Anglia, where most of the malting barley is produced. We had growers that couldn't physically get on the land to sow their spring barley. They gave up, they sold the seed back, they didn't grow a crop. If we jump forward 12 months, this is the average, this is rainfall against the average again for 2025. brown means very dry. So we had an exceptionally dry spring this year, which was good for sowing malting barley, but you sow in the expectation that it's going to rain, and it didn't rain. So we are anticipating lower yield, certainly for the spring barley this year, and we are anticipating potentially some impacts on quality. We may be seeing higher nitrogens, higher protein contents, which will suppress the PSY. So climate change is happening. What can we do about it? Well, one thing we're getting asked questions about from our customers is, what is the carbon footprint of the malt which you're supplying to us? So major contributors is the gas we're using in the maltings to dry the grain. So that's contributing about 25%. That's our Scope 1 emissions. And we heard earlier on from Nicholas about potential solutions to that. We have a major challenge in decarbonising our maltings and getting away from using gas as the fuel for the malt kilns. The second level then is the electricity. So we use a lot of electricity to move grain around, to blow air through the grain at different points. That's about 15% of the carbon footprint. That's our Scope 2 emissions. We are lucky in that we have 100% renewable electricity supply into all of our UK malting, so we're low on our Scope 2 emissions. However, the dominant contributor to the carbon footprint is the growing of malting barley. 60% of the emissions associated with a tonne of malt are coming from the growing of malting barley, and this is part of our Scope 3 emissions. This graph here is real data, so we're working with our grower group to, on a yearly basis, to gather data from their emissions, on-farm emissions. So this is data from about 40 growers in the north of Scotland, and this shows the breakdown of the emissions associated with the production of that malting barley. Now, we talk a lot about carbon dioxide and the effect of carbon dioxide on the atmosphere. Well, the gas we're concerned about here is not carbon dioxide, but it's nitrous oxide. And nitrous oxide is 270 times more potent than... Oh, we've got to do an update. There we are. Right, no updates today. So nitrous oxide is 270 times more potent as a global warming potential than carbon dioxide. So looking at this graph here, nitrous oxide is arising in 3 locations here. So we have the direct emissions associated with the application and of the fertilizer, the synthetic fertilizer that's being used by the growers. We've got some indirect contribution as well, and we've got a contribution which is coming from the manufacture of that fertilizer. So this is about 80% of the emissions associated with the growing and malting barley are related to the production and use of synthetic nitrogen-containing fertilizer. So our target is to bring these emissions down. The other emissions here, so energy used by on the farm, diesel for the tractor is pretty small. Crop protection, so this is the agrochemicals that might be used, the herbicides and the fungicides make a very small contribution, so it's really fertilizer. This section here, the 18%, that should be an easy win. So we should be able to move away from synthetic urea-based fertilizers into a low carbon production product. So something that we're particularly focused on is not just the absolute emissions associated with each tonne of malting barley that's being produced, but we're interested in this metric here, nitrogen use efficiency. So we could say to our growers, look, 80% of the emissions associated with nitrogen, don't put any nitrogen on your crop. And that's really not going to be very effective because they're going to get exceptionally poor crop yields, and we're going to get barley of a nitrogen content which really isn't going to be useful to us for malting barley. So it's about a balance here, and this is what this parameter allows us to evaluate. It's how effective has that nitrogen input been on the farm. So how much input of nitrogen have we got compared to the output of nitrogen in the grain that is being harvested? So our target for nitrogen use efficiency is a minimum of 70 to 80%. And this graph here shows this is yield, this is tons per hectare versus nitrogen use efficiency. And we can see that the more efficient growers are actually achieving higher yield through the efficiency of their nitrogen application. So there's a number of factors which will have influenced that nitrogen use efficiency. The previous crop, if you've grown legumes, they'd have put nitrogen into the soil. Barley variety is critical. High yielding varieties that use nitrogen efficiently will give us a high nitrogen use efficiency. When the crop is sown, certainly the type of fertilizer that's being applied, and then what you may have done with the previous crop residue. So we're working with our growers through a number of initiatives to help them to improve their nitrogen use efficiency. So how does that then tie into the varieties that we've been talking about? So these figures here show the tons per hectare that the farmer might expect to have got from particular varieties at the point in time which they were introduced to the industry. So if we go back to Optic was first grown in 1995. The farmer might have achieved 6.8 tonnes of grain per hectare of land use. And as we've gone through varieties, we've gone through Concerto, we've got Sassy and Laureate still being grown. Commercially, we're into the 7.5, 7.9 tonnes per hectare region. The newer varieties, Firefox, Diviner and Tennyson, over 8 tonnes per hectare, and the newest introduction, Belter, up to 8.4 tonnes per hectare. So this variety is still going through evaluation. Everybody is desperate that it makes evaluation because we all love the name Belter. So watch out for Belter in the next couple of years. It's a Belter. So if you go back to our PSY numbers and you work out increased yield, so from Optic to Laureate, the increase in PSY and the increase in yield on the farm equates to about a 25% potential increase in litres of alcohol per hectare of land use. So a more efficient, perhaps more sustainable source of malting barley. So how do our old varieties compare? So Chevalier, if we achieve 3 tonnes per hectare from Chevalier, it's a good harvest. And the problem with that then, it makes it a very expensive barley. So our growers who are growing Chevalier, we actually pay them by the hectare. We don't pay them by the tonne. We pay them per hectare of land which they've sown with Chevalier. So if we have a poor harvest of Chevalier, that's blooming expensive barley, which comes through to expensive malt. Marisotta, 5 tonnes per hectare, which is significantly lower than other modern winter barleys. And again, we have to compensate the grower for growing this variety with lower yield. And again, it makes that malt more expensive than the malt which is being produced from these modern varieties, modern high-yielding varieties. So if we go back to think about sustainability, these varieties are nice, but are they sustainable? In terms of the poor yield, they're high because of the lower yield. It means their nitrogen use efficiency is low. It means their carbon footprint is high. So something just to bear in mind if you're using older barleys, older varieties. Varieties tend to hang around quite a long time if they're successful. So this graph takes us back to 2009, brings us forward to what we are anticipating for 2025. So back in the late 90s into the 2000s, optic was very dominant, and if we took this graph back, we would get a big peak of optic. That was then followed by the first glycosidic nitrile-free non-GN variety, which found significant commercial volume, Concerto. Concerto dominated the distilling malt market through to really the start of this decade. And then we entered the era of Laureate, which we are still within. So Laureate is dominant not only in Scotland but also in England. And now we're starting to see the rise of some new candidates, the new kids on the block. And it's really whether any of these will start to start to take Laureate area. But you can see over that time period, we've had a whole range of varieties which have come and gone. So it's only one or two, maybe one a decade, which really cracks it and really is successful. So here's a possible solution to our sustainability question. This variety, SY Vessel. This is a winter malt. So same as Maris Otter, sown in the autumn, harvested in early July. And you'll notice that in the advertising of it, there's a glass of whiskey. So this is the first winter barley which is non-GN. Again, the parents were a winter barley and a spring barley. And if we look at some of the trial results, this is from a breeding company called Syngenta. If we look at some of their data, if you compare the application, 75 kilograms of nitrogen has been applied in this particular trial, 75 kilograms of nitrogen applied to Laureate, we see quite a significantly higher yield, tonnes per hectare produced. Now, the expectation is that a winter barley does not give you the same level of PSY as a spring barley, but does that extra yield balance out the amount of spirit that could be produced from it? So here's a little numerical exercise. So this is with real data, with real malt analysis data. So SY Vessel at a malt nitrogen of 1.40, nice for distilling. The Laureate has the same nitrogen content, a little bit lower predicted spirit yield coming from the Vessel, 418 from the Laureate, but the Vessel gave us 9 tonnes per hectare. And if we then work that through into the amount of malt that we would produce from 9 tonnes of Vessel or 7 tonnes of Laureate and calculate through with the PSY, we would actually get an additional nearly 650 litres out of the Vessel, even though there is a per hectare of land use. So there is a sustainable argument here for potentially using winter varieties, which the distilling industry hasn't used for a number of years. And we have trials of SY Vessel currently going on in a couple of major distilleries within Scotland. So quickly, we'll talk a little bit about speciality malts. We heard a little bit about the work that was going on at Maison Ninetti yesterday about use of speciality malts. So we sponsored a PhD at the International Centre for Brewing and Distillery at Heriot-Watt. This lady, who's none of us could ever pronounce Routel's surname, so she was just Routel to us. So she's now got a PhD, very successful, great piece of work, and the work that she did, which I think is supported by what we saw yesterday, is that speciality and coloured malts can be used in the production of spirit at low inclusion rates. The work showed that there were some changes in ester and higher alcohols that were coming through. Roasted aromas were carried over into the distillate. We never quite got to looking at different casks, but what we have done is actually evaluate the aromas and the compounds which are present during maturation to show that these different compounds do persist through the maturation phase. And this is now 3 years old. We're about to do the final assessment before it gets bottled. So unique product, a little bit higher raw material cost. You know, these don't come cheap. These speciality malts. But what was interesting, we'll skip through that one, tying back into Barry's presentation, when we were looking at some of the compounds which were present in the spirit, which had been made from these darker malts, 4-ethyl guarcol was found. So this is one of the compounds which we find in peated malt, in peated spirit. So do we have an opportunity here to produce some malts which will give us a level of peatiness? We'll never get Lefroy levels of peatiness, but if you just want that touch of peatiness, that might come through some modified malts which we could produce through in a roasting drum or a roasting facility. So again, going back to our friends at Holyrood, we're tying Chevalier here back into speciality malts. They feel that the speciality malts and Chevalier work particularly well together to give us some unique flavours and some unique qualities of the spirit. So I'm going to quickly finish up. Dave keeps looking at me, so it must mean we're time up. So let's quickly looking at a little bit on malt supply and demand, because there's sustainability comes into this as well. So the UK maltsers purchased from Crop24, over 600,000 tonnes of Laureate, Diablo, Sassy, Firefox. They're the four main varieties. So in total, it was 910,520 tonnes of barley. That gives us about 730 tonnes of malt. There's a lot of distillery expansions going on at the moment, and someone has calculated that the theoretical volume is going to be this figure here, just short of 500 million litres. That's on the assumption that all the expansions open and actually used at 100%, which at the moment is a little bit unlikely. But that's going to need around 1 million tonnes of malt to supply that. So there's a little bit of a gap there between what we're making at the moment and what is potentially going to be required going into the future. So this is the malting plants in Scotland. Apart from Simpsons is nearly in Scotland, so we count them. They're honorary Scots at Simpsons. So there's about 800,000 tonnes of production capacity at the moment. Bort malt are looking to increase. Soufflé Baird's are looking to increase at Inverness. My company, we're looking to put an additional malting plant up at Port Gordon, 120,000 tonnes. This will replace malt which is currently coming up from England. So a lot of malt is being produced in England, and it's coming up either by boat or by road haulage. So again, local production will help us with some of our sustainability goals. Apologies to Alistair that the Beam Suntory maltings are not shown yet on the MAGB map. Get that sorted. So that in itself requires a lot of barley, and we've got some conflicts going on here. So these sites, this map here, the circles and the diamonds, this shows the location of anaerobic and biogas production facilities which are in operation or being brought into operation in Scotland. And you can see there's quite a lot in the northeast of Scotland, which is where the barley is and which is where the maltings are. So we're seeing land being taken out of food production into fuel crop production to feed these anaerobic digestion plants. So there's pressure on malting barley availability because of that. Local wheat production now for grain distillers. We're seeing an increase in demand for that. Environmental schemes. Farmers are being encouraged to take productive land out of the crop rotation. They're getting paid for growing wildflowers and bird food mixes rather than malting barley. And we're now moving our farmers towards a regenerative agriculture processes, and that requires you not to grow malting barley every year. You're going to need to have more different crops in the rotation, which again is going to impact ultimately the availability of barley. That I think was the final slide. So thank you for your attention.
Thank you so much. So fascinating to find out more about malt and barley from a true expert. Fine. So we're moving on to our final chat of this afternoon. And just a quick one, we will have a quick break after this, but it will be in order to get, we have to be out of here at 5 o'clock. So in order to achieve that and have some questions, it will be quick out, grab a coffee and come back in, if you don't mind. But before that happens, we're going to have Lionel Creff from Tonnellerie Baron here, originally from Toulouse, from a family of, as he says, fruit farmers, bakers, and diamond cutters, which is fascinating. Started his career in winemaking. So here's wine coming back into our discussion. So he has the degrees in viticulture and enology. He's worked all the way around the world, and in 2001, he became a partner in this historic family cooperage in Cognac. And ever since then has been innovating with wood. So, Lionel, please, on we go.
Thank you very much. Thank you to the World Whisky Forum for the invite and for the opportunity to talk a little bit about our French forest. So, bonjour. We will talk about the French forest in French or in English with a French accent as you prefer. This is what you expect because you are here. So, the idea today is to talk a little bit about how the French forest is going. First, we talk about the French barrel production to give a few data about that. Then we talk about the French forest situation itself, surface, quantity. We talk about the way we select the trees to make a French barrel, because it's not a question of quantity, but a question of quality. So we discuss about that. And then we talk about few issues that could eventually impact the French forest in the future if we don't take care. It's the global warming, again, and the international market pressure. At the end, we'll finish on a positive note, I hope, with a perspective and solution for tomorrow. So the French barrel production is about 650,000 barrels a year. Globally in the world is around 4 million. Those numbers are changing a little bit, especially since last year. In US, the production is around 3 million barrels, and while in France it's 650,000. In France, we produce the barrel for French spirit, of course, like Cognac, Armagnac, also for wine, and we export 70% of our production. In US, to compare, it's very interesting because this is the bigger producer of barrel in the world. So they made they make barrel from American oak, not French oak, mainly, of course. And most of the production is sold in US for the Bourbon aging. And then it goes everywhere in the world, like UK, Scotland, Caribbean, France, also Europe in general. It's interesting to see that the sales revenue about those two industries compared in France and US is quite the same. So we can see that there is a big difference between the price of a French barrel and the price of an American oak barrel. And there is some reason, and we'll talk about the reason also. So the French forest is the fourth biggest forest in Europe. It is 31% of the surface of the country. The first is Sweden, second is Finland, the third is Spain, and fourth is France. Then we have Germany and a few other countries. This is 17 million hectares of forest. So it's very big. But to see that those 31% of our country is sequestrating only 5% of our CO2 emission, I think we have an issue somewhere. By the way, the French forest situation is pretty good, and this is a good news. Since the 17th century, Colbert, under Louis XIV, started a very, very strict plan of forest management. And this allows us to increase 78% of the surface of the forest in 150 years. We win 3 million hectares of forest in the last 30 years. It's very interesting to see that we have a net balance in France of 36 million cubic meters per year. So this is quite surprising because we hear a lot of noise, like forest is going down, we have less forest, etc. But in fact, it's not true. Our forest is increasing a lot because it's very, very well managed. But the structure of the forest is changing. And this is due to different reasons. But globally, we can say that we have a forest which is in very good condition in France so far. How we select the trees to produce French barrel. So in the previous one, we saw that 41% of the forest area in France is oak. And after we have a lot of other trees, but 41% is made of oak. So it's 7 million hectares of oak in France. The main oak type we use to produce barrel are Quercus petrae and Quercus robur. In US, it's Quercus alba. And those Quercus petrae and Quercus robur, we also have hybrids. And those trees that we are using to produce barrel are 1.6 million hectares. So only 23% of the French oak forest. Then, to produce an oak barrel, in France, the French oak need to be splitted to follow the grain, otherwise we will have leaks and the barrel cannot be used. So it's very important to follow the grain and split the grain and split the oak to produce the staves. And so for this, we are looking for very specific oak trees with the biggest diameter as possible, very straight. And so, again, it's higher selection. And so less than 1% of the oak resource we have in France can be today used to produce oak barrel. So very, very high selection. To compare, so to produce American oak barrel, the Quercus alba doesn't have the same consistency and can be sown in any direction. So there is a better ratio of use. To give you an idea, 70% of the American oak tree can be transformed in a stave, when for the French oak it's only 25%. So we have 75% of loss on French oak when we have only 30% of loss on American oak, because it's a different species. So this makes a huge difference, and maybe it highlights you on the fact that a French barrel of the same capacity will cost probably 4 times or 5 times more compared to an American oak barrel. So here you can see that the perfect oak we need, it's on the left. It's tall, high diameter, straight, because we split it and to follow the grain, so it has to be straight. And we are looking to get the best of the forest when we purchase an oak tree. So globally, we see that the forest is in good shape. The surface is growing. The net balance is good. And everything should be okay. But like for many other industries, we are facing the global warming. So the global warming will affect the forest in 2 main ways. First is the drought. The last few years, we saw that the mortality has increased by 54% in 10 years in the forest in general. And this is mainly due to the hydric stress, which can lead to death. In fact, 50 years ago, during the summer, we had a lot of storm with rainfall in July, August. Now, most of the time, it does not happen. When it happens, it's very strong, and all the water go away because it doesn't reach the roots of the trees. And so the tree, which at this phase of his life, when he has the leaves, needs a lot of water. He's pumping the water from the floor, but nothing arrives because it's dry. And so we start to have a phenomenon of cavitation. And the cavitation means that all the small pipe in the trees which are bringing the water on the top, we start to close. And so the water doesn't reach the top, and the top of the tree, even if it's a very old tree with very deep roots, the top of the tree will start to dehydrate, and then little by little, the tree may die. Also, because there is higher temperature, the tree needs more water than before. So he has less water and he needs more water. So there is an issue there with the climate change. The trees also have a slower growth because there is less water available. So the CO2 sequestration is lower, and also the growth of the tree is lower, so it generates less wood. We also have a reduced wood quality because of this lack of water, and the tree starts to be weak. And this weakness also is an open door for other disease. So the other disease mainly are bug attacks, and you can see on this picture, in the same forest, so here it's not oak trees, we don't do barn with that, it's pine trees, but we have the same issue in the two kind of forest. You have a corridor. On the left of the corridor, the trees are attacked by bugs. So in French, I didn't find the name in English. In French, it's scolite. I don't know if you have this word in English. I did not manage to find it. I saw bark bugs or something like that. And so those bugs, because the temperature are increasing, they have a longer life cycle, and so they are developing more, and they are colonizing more areas, and so they are growing faster and stronger in the forest, creating more and more attacks and more disease for the trees. So it damages also the wood, reducing the yield for the final usage, for the cooper, for example. When we have bugs in the trees, they create change in the coloration, change in the structure of the wood, and so it's a loss for us when those bugs start to attack the oak. And also, this is less CO2 sequestrated. It's difficult to say. And it's even enhance the climate change. So it's a bad cycle. And it's a big issue for the future if we don't work on that. The other issue, which is important also for us, is the international market. There is a cooper who wants the best forest, the best oak in France to produce the best barrel. But there is also some global buyers and in France, but also foreign, mainly from Asia and mainly from China, I would say, that cannot cut any oak trees anymore in China. It's forbidden because they cut too much oak trees. And so the government say, no, it's finished. It's forbidden to cut an oak tree in China anymore. And so they went to Russia. They start for 3, 4, 5 years to purchase oak trees from Russia to produce floorings, furniture that will go in US after, or in Europe, or anywhere in the world. And Russia say, stop, we don't sell any oak trees anymore if the oak tree is not transformed in Russia. Good. And then they came to Europe. They start to purchase oak trees in Romania, in Bulgaria, in Hungary, in Germany, and now in France. And so we have to compete with those people. And you may know that the way we purchase the oak trees in France, it's on auction. So you go, you evaluate the lot, you give a price, and the one who gives the bigger price will get the lot. So depending on the kind of business you have, you can put an amount of money on the lot or not. And the last few years, it has been very challenging for us to be able to get some lot at a good price. And that's why the price of the cubic meter of tree have increased from 500 to 600 euro per cubic meter to 1,200, 1,500, and even 2,000 euro per cubic meter, depending of the location of the forest. So big challenge there. What are the perspective and the solution for tomorrow? So first, we have to adapt our forest. So the global situation is not bad so far because it has been very well managed for centuries. And we also have very good offices like ONF in France, or public offices like ONF, Office National des Forêts, or the CNPF or IGN also, which are working a lot on the forest management by doing a lot of research and development. So this is very important to continue this research and development. And there is a lot of money which is sent by the state to really work on that, because we really understand that the forest is a very strong, and it's very powerful in the country. It's something very important for the industry, the climate, and also for the landscape. Then we need to incorporate new species. So those offices are doing a great job in trying to find which species of oak will be better adapt to the climate change. So in south of France, for example, in Mediterranean area, there is the pubescent oak. We don't use it too much so far in the cooperage industry, but those pubescent oak has been grown now in the northern part of France, and we see that it adapts very well to the drought and to the higher temperature. It's also less impacted by the bugs. And so we start to plant a few blocks of those trees in the middle of native forest to get those pubescent oak to mix with the petrae and robur, and to create new hybrids which will be more resistant to the drought. And so this is probably a huge potential to keep the French oak forest in very good shape for the future. We need also to accelerate planting, because we see that the mortality is increasing. So it's, to me, very easy to understand that we need to plant more. So it's well done so far, but there is a few private initiative, and we do one. Since 2018, we plant 1 oak tree per barrel produced, so it doesn't seem to be a lot. But since 7 years, it's 230,000 new oak trees which have been planted. So if everybody does that, every user of oak will do that, that will be a great step also, I think, to preserve the forest for the future. And then a smarter forest management, like we do some observation. There is more and more technicians who are checking the forest all year long, walking into the forest to check the trees, marking the trees, to see which one is sick, which one could be sick soon. And so we cut the sick trees before. We also use a satellite picture drone to check where in the forest there is more and more disease and where we should cut before. So we are changing also the way the forest is managed, and I think it's a good way to go. Another point is a better usage of oak. So I think the barrels are built to last. This is the subject today, and yes, the barrels are built to last for sure. Our cooperage is 150 years old, and we are fixing barrels that our grandfather have produced in 80 years ago. So it's very interesting to see that if the barrel is well maintained, and well managed, we can use it a lot. There is also a few coopers who started to develop more connection with the used barrel industry. So they are starting to do some contract to get back the used barrel, to resell it to other type of customer. So a barrel from Saint-Emilion could easily go in Portugal to make a Porto, and then from Portugal could go to rum in Jamaica, or maybe to Scotland, and then from Scotland going back to tequila, etc., etc. So a barrel can last 100 years with no problem. It just has to be well maintained, and we have to be aware that the trees need 200 years to grow. So if we can use it as long as we can, I think it's a good way. This is very French now, but I think we should keep our French oak resource to create value on our territory. I think this is a very important point. We have a savoir-faire to produce oak barrels since many, many years. We started to produce the first barrel 200 years before Christ. We should be able to continue for a few decades, or a few centuries, if we give us the oak. So this is a main point. To ship French oak in China to create florins and to sell it anywhere in the world, I think has a bad impact on the planet, for sure. And on top of that, it removes value from what we could do here. So we should be... we work a lot on the state for this point, and we will manage to get something, but it takes some time because the laws and the rules and regulation are difficult sometimes. We also need to optimize the oak usage. When we cut an oak tree, we need to be sure that every single part of the tree has been properly used. And I think that today every cooper is very aware of that. And once we cut a tree, we try to get as much as we can from it. So to conclude, I think I'm good on the timing. To conclude, I think the French forest is pretty well managed so far. We have some challenge we need to face. We are in a good way to be able to face those challenges. And I think maybe my grandson will be able to talk in the Cité du Vin for the World Whisky Forum to talk more about the oak barrel and the French forest. Thank you very much.
Thank you so much. Bring it in on time. I love you. Right, everybody. Quick cup of coffee, quick comfort break, and I will get my esteemed colleagues on the forum to drive you back into the auditorium so we can get some questions. Thank you. Okay, folks. We have the cube. Zoe is clutching the orange cube. We've got to be out, as I said, we've got to be out here at 5. Not at the building, out of the auditorium. At 5, and then we've obviously got the tasting. So, 45 minutes, roughly speaking, for some questions. I'll kick off with a couple, and then I think there was so much amazing techie, geeky stuff going on there. I want more contributions from you guys for this one rather than me hogging it all the time. So I'll stop talking and asking questions. This is to all of you. Maybe start with you, Barry. I was really intrigued by the practical application of all the research that you're doing. And does this mean that either now or perhaps down the line that the distiller will be able to almost like tailor make the peat level or even the aromas of flavor within their whiskey, thanks to your research? And the same then applies to the other.
Yeah, I mean, I think that's sort of the general, not the general, but one of the broad themes of the work we do is looking at controlling flavor and how you can do that better, understanding flavor chemistry, where everything comes from. But like we were learning about in distillery yesterday, really there was some good applications of changing the process, seeing what happens composition-wise, and understanding the impact. But yeah, trying to apply that to all parts of the process, including peating. Yeah, but yeah, I saw you nodding away there when I was talking about the control that's available at the minute in the kiln, in the maltings. So while you could apply some more, I mean, I think monitoring things like temperature would help, but actually having the control that we have in the lab would take a step in terms of process.
So it's actually a challenge to Dave.
Yeah.
Really. More efficient kilns, please.
As usual, the malts have to do everything. And I think it's interesting in that, I mean, I think us in common with most of the other maltsters who are producing peated malt, we're taking the peat from one moss, St Fergus in Aberdeenshire. When we occasionally are asked to produce peated malt with peat which has come from other locations. And certainly when we do that, we do see some differences in, firstly, how the peat burns, and then secondly, the sort of some of the analytical properties that we get out of it. So there is, and Barry's work has shown it as well, that there is some geographical differences. So you could potentially start selecting, your source because it gives you particular attributes. And building a little bit on the work that's going on at SWRI. I mean, our aim is to use peat as efficiently as possible. So we are aiming to produce the highest level of phenols that we can deposited onto the malt, and then it's accepted that we then blend that down to a sales gravity almost. You could imagine it's all like high gravity brewing. You're blending it down to a level. So we deliver a lot more peated malt than peated malt we produce because of that dilution effect. So that's one of the ways in which we're doing the utmost that we can to minimise the amount of peat that we're actually utilising.
And are there, innovations in terms of kilning techniques that you're looking at?
Not yet, but I think that will come. I mean, I think I explained on my presentations that we no longer use peat as the main fuel. It's burnt in a separate furnace, and that peat smoke is then ducted into the kiln in the early stages of kilning. Now, the work on airflow is very interesting because one or two people in the audience might be aware that we actually managed to burn our peat kiln down a couple of years ago.
I wasn't going to mention it, but
which we have now fully rebuilt and is fully functioning. So peated malt is fully available from us again. But then there was in doing that rebuild, there's some innovations which have gone into that, which includes a little bit more control of airflow. So that is scope. Controlling temperature is pretty difficult because the stuff burns like billio. So that's a harder one, but certainly the airflow opportunities I think would be interesting to investigate further.
Yeah. And Lionel, I was looking at more information about the company. You're doing a lot of work with wine and increasingly spirits, and you are tailoring casks to create specific flavours. Could you explain a bit more about that element of the business?
Yes. So the scale of our company is not huge. We produce 15 to 18,000 barrels a year. So we try to create high value barrels for very specific product. So we do that for the wine industry. So we do barrels for Petrus, for Cheval Blanc, Opus One, Vega Sicilia, etc. So very, very high quality wines, and also for spirits. So we do work with Remy Martin historically. Plantation, the rum, it's Planteré. So we do a lot of research for them. We do some very specific toasting. We change the location of the seasoning of the stave. So we do seasoning of stave in different altitude, different areas near the ocean, in the mountain, etc. And we develop some very, very specific toasting regime to try to match some specific flavor. So it's not a mass production. French oak is expensive. It's absolutely different than what we can get with a cheaper barrel from American oak, which is very good, and we need it for sure. And we do a little bit. We import a little bit of American oak staves, and we do some few American oak barrels, and it gives some very, very good results. But yeah, really our focus is to try to develop for specific products, specific aging, specific target, a specific barrel.
And have you noticed, and I remember this being said years and years ago, that there was a difference between wine quality wood and spirit quality wood. Is that still the case, or is the spirit quality wood now becoming more like the high spec that wine has always wanted?
So in fact, it's not a lower or a better quality. It's a different quality. So it's true that historically in the spirit business and in cognac, because we are from cognac, we were using the large grain, so trees which had a faster growth for cognac, and we were using the tight grain for the wine industry. But it's changing. It's changing. So it's generally true still, but it's also changing because we are looking for new flavor, new storytelling also. As you know, in the spirits industry, storytelling is important. And also the barrel has a huge impact on the flavor, and so by working on the grain, working on the oak origin, etc., you will get some different flavors. So it's not so historically and globally, it's true that the oak type we use for spirits is larger grain from French oak, but it's changing.
And I'm interested from all of you, who generates the research, for example? Do distillers come to you and say, we would like to know more about this particular thing, and can you apply it because we want to use it? Or are you pioneering stuff yourselves and then taking it to the industry?
For us, it's a bit of a combination. Well, we agree what the research program is, but yeah, there's certain things that the industry are interested in, and maybe how they tackle it is then for us to come up with the ideas, the ways to do it. The broad sort of sustainability theme for us and being more efficient in the process is across the board. Everybody wants to know about that, but then how you can meet those requirements is something for us to think about with the distillers and agree on.
I think for us, we would probably go to Barry as well for assistance on certain aspects. And we've got some, I guess, non-routine analytical methodologies that we can use more around product support and malt-type support and use support, rather than, we're not in the business of doing pure research anymore. I guess a lot of our evaluation, we talked about the barley varieties. That's one of the areas which the individual malting companies are quite invested in. We all have small-scale malting equipment where we participate in national trials in order to contribute the data, which then goes into the system, which allows the evaluation and the continued improvement of the varieties which are coming through to our ultimately for our customers' use.
And now, which way around is it? Are you innovating in terms of casks and then taking it to the industry, or does the industry come to you and go, I want to make this particular style of cognac or whiskey or wine?
So sometime when we have an idea that we think it's good to develop, we work on it and we develop it and we offer it to a customer who may be interested in using it. And but most of the time it's a request from a specific customer who is looking for something different, and so we work for him specifically on this product. So there is a two way of doing. Either we are convinced that our idea is great, and so we do it, and then we introduce it on the market, or we work specifically for specific research, for specific demand from a customer.
Okay, I'm going to throw this open to you guys. Actually, literally throwing it open to you. Any questions? Yes, Sir Benedict. Oh, here we go. Here we go. Straight in
you
the
hear me?
back of the portree net.
No, I think it works. All right. Barry. Has there been a change in the phenolic composition of Islay whiskey from, let's say, 60 years ago to today?
From 60s.
Yeah.
There shouldn't really be. The peat's not really changed that much in that time. Particularly the way it's cut in some of the places in Islay on banks, and you're cutting the sort of the same level all the time. And I can't really see why there would be a difference in profile.
Most peat coming from Aberdeen nowadays on Islay production?
Islay is Islay peat mostly. A few sites on Islay, but they're more similar to each other compositionally than Aberdeenshire versus Islay. And there's a more of a common theme there. So, is this based on observation or?
No, I was just told once from a friend at Diageo that Port Ellen Maltings is receiving a lot of, if not all, peat from Aberdeen nowadays.
Yeah.
I wonder if that has an impact on Islay profile.
I mean, I know there's been occasions where they've had to take peat from outside or off the island because they couldn't get the peat dried, and then that did have an impact. But
maybe just rumors or speculations.
Yeah. But no, I can't think of the science reason why that would be.
Ladies and gentlemen, the first question from Brendan McCarran.
Hello. So I used to run Port Ellen Maltings a while ago, so it's like 2011 to 2014. And this is the bit where Barry's going to, headbutt me outside. But we would, not frequently, but we would switch into campaigns of Castle Hill 1 and Castle Hill 2 peat moss. And then there'd be other times where we would switch over to Aberdeenshire peat as well. And I know, and I've had to face this in tastings my entire life, I know that on a lab scale, there's really noticeable differences. But when it scales up, you're talking 52 tonnes in a kiln and about 5 or 6 tonnes of peat burnt with it. The differences were not night and day. No, we would try lots of blind nosings. And I thought actually one thing that was even more important than the makeup of the phenolics was the moisture content of it. If you got nice wet peat, you could just make brilliant peaty barley, and if it was dry, it was just a nightmare. But yeah, it's been very common for about at least 70 years for both Islay and Aberdeenshire malt to go through Port Ellen malts. No, you can't rehydrate it, it's true. But the other thing you do, which actually, sorry, I'm now starting to just hold court here, but Barry, you were talking about if you get a huge amount of peat coming out of a project, and then unfortunately you won't be able to use that all up. That's actually okay. There's enormous big sheds at maltings where they pack all of the peat together, and it's like there's almost a skin on the outside that gets dry, but everything in the middle stays wet. And obviously that's the bit that's ideal. So we've had like 2 years worth of peat stored away in sheds before, and it's for the benefit of the quality. But yeah, if you spray it with water and stuff, it looks like you're having a great time, but it's actually steam that's coming off the peat, and then you check the phenols at the end, and it's shit.
Thank you for the technical term. Any other questions? Sorry, I can't see. Oh, yeah. Oh, well, sorry, Magla, I didn't see you there. Yeah, and then Dawn. Okay.
I have a question for Barry. In peated whiskey, we have a high level of volatile phenols, about several milligrams per liter. What about the toxicity at these high levels?
Toxicity of phenols?
Yes.
Well, as I say, we do have our product protection group at SWRI who look at these sort of things and making sure that they're not at a level that we would be concerned about in terms of daily intake. Because, yeah, if you drank an awful lot of phenols, same as anything really, it would be toxic. But yeah, the levels that there are there and the levels that you can intake daily is not an issue. You could.
So today we saw the terroir can impact the wood and also the peat, and what does it for the body?
Sorry, Alex, would you mind just repeating that?
What is the impact of the terroir for the barley?
Ah, now that's a question, isn't it? So I'm going to be terribly controversial here and say, in my opinion, it has no impact whatsoever. Variety, yes. Where it's grown, no. So I'm sure people may have a differing views.
Well, I know one person, but he's out of the whiskey industry, so that's why.
So people may even agree. So
he believes Vikings invented whiskey, so you know. No, sorry, I don't mean no. Put your hand down. Dawn, you've been very patient. Yeah. Yeah.
So it's been a long time since I played rugby. It's a question about the forestry in France. We know that a lot of the problem with sort of grown forests or the lack of biodiversity. Is there quite a lot of research going into that? And is that also problematic? Because if you need the tree to grow straight, to have more biodiversity, I presume, is also challenging?
Yeah, so there is no forest with only one type of oak tree. It does not exist. There is some forest with mainly Quercus petrae or Quercus robur, but everywhere in France, unless in not too far from here, which is an artificial forest. I don't know if you have been already on the road between Bordeaux and Biarritz. You have a large surface of sand, which has been planted with pine trees in the 18th century to dry all the humid area where nothing was growing. So this is the only forest, the only case. Otherwise, in France, everywhere, in the natural forest, we have the biodiversity. We keep this biodiversity. We just manage it to try to keep it as much as we can. And of course, this is a very, very important thing because, as you may know, the birds help to bring the acorn to other places, to grow new oak trees, etc., etc. So biodiversity is one of the main points that is really looked after by the state.
Thank you.
And Chrissy, you had a question, right? Don, try and hit the second row. It's so you're like a cube magnet. Or people just hate you, I don't know.
This is a question for all of you. It's an unfortunate thing in the world right now that governments and some industries are moving away from sustainability pledges. Are you seeing that at all in whiskey, or are the big players at least as committed to making sustainability gains as they have said they've been?
I'll go first on that one. We're seeing no change whatsoever at the moment. If anything, it's accelerating. When I had lunch, whilst I was having lunch, I received an email from a distiller asking for particular bits of sustainability information. It's a daily job for us. I mean, I have a sustainability coordinator. Now it needs specialist people to do that. So the bigger issue that we have is that everybody has a slightly different definition of sustainability. Everybody wants a little bit different data. Everybody's collecting data slightly differently. So we need some standardization around this, and that's where we really need government to dictate to a certain extent what the data is we should be gathering.
Regarding our industry, we have been working a lot on the sustainability since 10 years at Baron Cooperage. And we have been pushing a lot at the French Federation of Coopers for them to create a specific office to work on that. And after 9 years, this year, we have a specific office for the French cooperage, French Federation of Coopers. So it's working. Something I see since 2005, every year we do a booklet called Low Carbon Footprint. So we give our carbon footprint to every of our customer or provider for them to understand what we do to decrease our carbon footprint and which solution we found and where we are today and where we want to be tomorrow. The first time we released it was in 2015 and nobody asked for it. 2016, nobody asked for it. 17, nobody asked for it, or few. 20, 21, 22, everybody wanted it because it was the lockdown, they have nothing to do, they watch the TV, they understand that climate is changing, we have to do something, we need to buy an electric car, etc. And since 2 years, nobody is asking for it again because they have other preoccupations, they need to sell the wines, they need to sell the whiskey, they need to sell the barrel, etc. So it's true that when everything goes well, everybody is concerned about the climate change and the carbon footprint and the sustainability, but it's also true, to be honest, that when things are going bad or not as good, they are trying to look about what they have to do every day and not taking care too much about the sustainability. But as you say, it's an everyday job and it's the job of everyone. So I think it's important for us as owner of company to talk about that to everyone we can try to get to join this subject.
Perfect. Any other questions? Oh, Zoe. Oh, I did.
Someone will have to
Here we
catch
go.
in between. No, that's easy.
Yeah.
Thank you.
At least it missed Norman.
Mainly a multi-question, but if we've seen recently with I suppose it's unfair to the big guys, but particularly with the smaller guys, a lot more of a focus on using heritage varietals of barley because of the story that we can tell about flavour and, tasting new make, Marisotto new make, and just getting so excited about the flavour opportunities there versus the main varieties. At what point do you think you as maltsters would have a responsibility to inform your clients that the story they want to tell about flavour might actually be in tension with the sustainability direction? So they're picking a varietal of barley that is much more exciting for flavour, but it could be, would you go as far as saying actively damaging the environment or damaging their sustainability credentials to go for a varietal that has such poor nitrogen efficiency in comparison with the main strains? Like, is that your job to tell them?
I think it's our job to inform them and keep them informed of it, but in the way we've done that today. I don't think we would say to people, you mustn't use it. We would just say to them, look, in terms of our contribution to your carbon footprint, it's going to be higher if you choose to use Marisotto or Chevalier than if you're working with Laureate, and then it becomes their decision as to what they do about that. That may come down to financials more than anything else at the moment. So I think it's getting that message across. The craft. It's quite interesting when we talk about sustainability. You almost see that the big guys are seeing it almost as an obligation, whereas the smaller craft producers, beer and spirit, they see it as an inherent sort of need to do. So it's almost differing messages for differing parts of the industry at the moment.
I was wanting to pick up on the idea of kind of regeneration, because it seems to be something that applies to all three of you. But Barry, maybe talk about the peat restoration and regenerate. How do we bring peat back to life in the bog rather than just throwing water on it in the maltings?
Yeah, well, that's not exactly what needs to be done, but yeah, in the degraded bogs, it's a case of blocking the drains and letting the water table rise up again to hopefully start forming peat again. It's just the general principle. I mean, there's quite a lot of work into that and how successful that can be, because it takes a long time to do that process. You know, it's decades to recover a peat bog, so it's still not fully understood how close to a fully functioning or original state of bog you can get to, but it should certainly at least be sequestering carbon again, acting as a sink. But yeah, there's plenty of work going on that, and probably one for Alistair.
Yeah, I was going to bring in Al at this point. Chuck on the cube. Yeah.
Yeah, so every bog will be different in its restoration lifetime. It depends on the degradation of it. As Barry says, it's a hydrological unit, so fundamentally you want to stop the release of water from it and bring the water table back up. It will take years. A reasonable condition bog that you put back the water table to just near subsurface below the acrotelm, you could get restoration occurring within about 10 years. More heavily degraded, 10 to 20, sometimes a bit more. Will it ever get back to the state it was in before it was degraded or harvested? Probably not, but it will still be able to, through the formation of sphagnum, which is the building block of peat, get into a condition where it stops emitting carbon, can get to the point where it can start to sequester carbon. But of course, during that phase of restoration, it will become quite a serious emitter of greenhouse gases. It will release a lot more methane because you're disturbing it. But it is possible to put back, it is possible to get a bog healthy again. But it's a slow process. It's even a healthy bog, it's 1 millimetre a year. Yeah, it's a long process. If you dig a metre down in the ground in a peat bog, you're digging 1,000 years history out. But it can be done. And it should always be remembered the forests are very important. We need them for casts, we need them for so many other things. 30% of the Earth's surface is in forests. Only 3% is peat bog, but there's twice as much carbon in that 3% peat bog as there is in the global forest. So it is an important area for us as an industry and as a global community to focus on.
Right. Thanks, Alan. I know you'll be talking more about all that tomorrow. So but thanks for that. I mean, talking about long process, I was really excited about the pubescent oak. And I was thinking, that's great, that's amazing. No, yeah, you'll find out about that in 200 years. But could you maybe amplify on what work is being done in terms of regenerating forests and making them?
Yes. Since since the 17th century, so Louis XIV understood that the forest was very important to build a ship for the war and to go overseas and find new lands, etc., etc. So since that time, there is some offices in France who are managing the forest. 75% of the forest is private, 25% of the forest is public. But they all have access to those offices to help them to regenerate, to find a good way to regenerate the forest correctly. So the research is very important, and since many years, they observe that the trees are weaker. There is less big trees. So the surface of the forest today is bigger, but the average age of trees is lower. So it's a younger forest. And so this is the issue for us, Cooper, because we need the big ones. They do a lot of work to try to select the best species for each region. And there is a lot of communication on that to the forest owner. And a lot of money which is put on those programs in general.
Fantastic, thank you. And in terms of barley and regenerative farming, are you involved in that process as well?
Oh, very much so. So we saw some of the greenhouse gas emission data that we've been collecting. So we've been collecting that over the last 3 3 harvests, and we're now moving to introduce a regenerative agriculture framework to our growers, where we can hopefully now start to work with them in order to start lowering those emission values that we're seeing. We saw that nitrogen and nitrous oxide from fertilizer production, fertilizer use is a major contributor. So we're aligning ourselves with the Sustainable Agriculture Initiative Regenerating Together framework, which we see is going to become sort of a globally accepted standard. There's a lot of I hate to use the word misleading information in this area from certain parties, and we're working very much to make sure that everything we do is fully verifiable, fully auditable, fully transparent, because we feel that it's necessary to work to that level of detail. So we're encouraging our farmers. I think at the moment I would probably call them sort of reluctantly positive about this. Like anything to do with farmers, they're not that enthusiastic to make changes. But looking at improving soil health, looking at improving water availability, looking at biodiversity, cover cropping, and all that sort of thing. A lot of them are doing it already, and they don't know they're really doing it. So we're at the moment we're surveying them to fully understand what practices are currently being carried out on farm, and then working within our grower groups to encourage knowledge sharing, and to develop a more regenerative agriculture culture.
It seems an appropriate time to bring in the fielding guys, wherever you are. Chico. There we are. Come to the queue. Drop.
We started to look at what the effect of growing grains in different ways also would mean for soil health, biodiversity, and carbon footprint, as well as nitrogen. But it's still very early stages. We only have one harvest of data, and we need several to verify exactly what is happening. So we cannot comment so much on that. Overall, so far we see some nice numbers, but this has to be tested for at least probably a period of 5 years, growing in the same locations, to see what exactly is happening with this, with grains growing with cover cropping, not plowing, versus, let's say, conventional way of farming with introduction of synthetic pesticides and herbicides, fertilizers, and so on.
Great. Well, thank you. Any others? Sorry, Brendan. Oh,
not bad. I can't remember the exact units, but roughly, there was a figure about peat usage being 0.0003, so tiny. And then it sounded from David something that's relatively solvable, which was 18% or something of fertilizer that's being used. So are we guilty of, we've given a lot of attention talking about peat today for sustainability, when is it the wrong thing to be looking at? Should we not be looking at dull, boring fertilizer instead?
Well, I think we need to be looking at both. Yeah, I mean the thing about the peat is, it's a small quantity relatively, but I think a lot of it's about the perception of using peat, and making sure you're talking to Alistair, about if you're trying to look at getting or new licenses to peat bogs, you have to demonstrate that you're being responsible in how you're using it, and to make sure that we do have a supply of peat, we need to demonstrate that, I think. So despite the fact that it is very small amounts, we do need to be responsible with it. And it is important, I think, to look at that, as well as fertilizer, something else.
Can I just jump in there before you answer that? Do you think at the moment the whisky industry is aware of this, but the public might not think of peat and whisky at the same point because it's a small amount? But all of a sudden, as soon as horticultural ban on peat comes in, peat's used for whisky is suddenly going to be 50%, 60% of the peat extraction, and suddenly, you're the bad guy. Are you prepared for For,
I think,
for
well,
us.
probably not the SWI's
Probably not
role,
you,
role
yeah.
to, yeah, if
Yeah.
we hide behind the SW and
Yeah.
let them deal with the public. We provide the science, obviously, to support what they're doing. But yeah, that's what we're preparing for, is that closer look on the whiskey industry as the peat user, or a bigger peater user, as a proportion of what is being used for industry or different industries. So yeah, I think us and the mushroom farmers would be the big users. So yeah, again, making sure that we're demonstrating the responsible use will be important for that.
And sorry, Dave, if you want to pick up.
I mean, I think in terms of peat usage by the malting industry, I mean, it contributes to our Scope 1 emissions, the burning of it. I think it's more the depletion of the bogs, and it's the land restoration, which is the important part there. If you think about the 18% of our greenhouse gas emissions, which are down to nitrogenous fertilizer production, yeah, it should be fairly straightforward to swap it out. The problem is a lot of these low carbon fertilizer at the moment are significantly more expensive than conventional fertilizers, and the farmers want to be paid for doing sustainable work. They want to be paid for giving you a few numbers, which is in their nature. So I think as we see, we're working with a company called CCM Technologies, and they're producing a low carbon fertilizer, which is using some of the output from AD plants. When they show me the production process, there's a big black block in the middle, which is the bit we're not allowed to know what goes on, but that's actually a carbon positive fertilizer. It's actually sequestering carbon out of the atmosphere as part of its production process. So, we're doing some trials on that. Last year we did some trials to evaluate its impact on yield in the field, and there wasn't anything. We've gone through the malting of that barley separately, no impact on quality. So we're looking to encourage our growers to start to utilise this material. It may need some financial incentive, which may have to come from our customers who want regenerative barley to be able to achieve that. But as demand grows, then production levels will increase, and it will, the cost will come down to parity.
Okay. It all comes down to cost. Yeah.
It all comes down to money from somebody.
Yeah. Yes.
Thank you.
Enormous.
What is the annual sort of consumption of peat for whiskey?
What's the annual?
In tons, how much peat is actually consumed?
About 8,000 to 9,000 tons would be the.
Could that be achieved through taking it from like a waste product from infrastructure projects?
In theory, but it's being. It's the practicality of doing that, which I think maltsters are investigating now with trials that we're running.
Yeah. On quality or timing, is it trying to get it
things like being able to get it down to a dry level. There's no space in construction sites really to do that, and they wouldn't let you just lay it out and dry it. So yeah, it's being able to.
It would have to come off site.
Yeah, that sort of thing to understand. But in theory, I think there is quite a lot, and is it practically usable is the question.
Yeah, has anything been done on the kind of quality of the differences, but in different areas? Right now, most of the peat's coming from one place.
Yeah, so that's what we've been looking at, is taking samples from construction sites and looking at them in terms of composition and flavour that they give, making sure they're not hugely out with the realms of.
And are they not?
No, yeah, which is surprising in some ways, because some peat bogs are quite similar, but the one we've been trialling has got a lot of trees planted on it, which is quite different from another peat extraction site at the minute. So if there was going to be a difference, you might have expected that, but it's not. I think, as Brendan says, different sites they're not night and day. They're going to be. There's a common theme. Lots of them are based on sphagnum, but there are differences to look out for. We do look at that, and that is an ongoing study at the minute.
That's cool. Any others out there? No. Okay. A quick question about yield and efficiencies, because if you talk to a lot of newer distillers, they're sort of saying, well, we want to make whiskey with better flavour, and the efficiency and the yield doesn't matter as much. If we can maximise the flavour, the yield doesn't matter as much. Are you noticing that? Are you noticing this demand coming, and how does that? How then do you cope with that?
Well, I think a lot of that is coming through the use of different barley varieties. Yeah. I mean, if you're chasing volume, you won't be using Chevalier. You'll be using Laureate at 420 litres per tonne rather than Chevalier at 350. Whereas if you're looking for flavour, then you'll be using some of those the older varieties, which clearly do give different flavours in new make spirit. Now the question is, does that persist through maturation? And I think we're only really starting to see those sort of products come through, and it clearly does seem to do so. So I think it's horses for courses, depending on what your business model is based around.
But given that there does seem to be a rise in this trend, it's almost like a parallel stream to the highly efficient distillery that has to produce a lot because that's the nature of the business. Does that then mean, given it is a trend, does that mean that the maltings have to be more flexible, that you have to build in flexibility of being able to process barleys which take longer to germinate, that you can't just put it in one end and take it out in a 1 week, 2 week cycle?
There's an element of that. There's also an element of batch size. So if we talk about Chevalier, we produce 300 tonnes a year of barley for that. I mean, we could process that in one batch, but we won't. We'll do it in. So you need plants which have got smaller batch sizes to do that in. Which we're fortunate in having that facility. Other maltsters don't. So I think we need a level of flexibility around that. And it's true. When we first malted Chevalier again for the first time over 100 years. I mean, it was obvious it needed extended germination time, which was its nature at the time. So you can't process it the same as you would do Laureate. You've got to accept that it's going to need more processing to achieve the final end result, which obviously impacts on capacity of the plant as a result. But it's only a little amount. So if we were malting 30,000 tonnes of Chevalier a year, then I think it would be a different different problem for us.
And Barry, are you noticing, in terms of being approached, that are you seeing this trend of people saying, actually, it's flavour driven rather than efficiency driven or yield driven? Is that an area that there's any research going into, or?
Yeah, it's both that we get asked about. I mean, primarily efficiency is the main thing, but also there's flavour. Say we're looking at studies on yeast. It'll be both things. There'll be flavour diversity as well as efficiency and able to cope with high gravity and all these sort of things. So yeah, we get the range of questions. And I would say in terms of my area in raw materials and processing, there's been more in the last 20 years on flavour and understanding more how to control flavour or diversify flavour in the earlier part of the process compared to back in the early 2000s when I started. That was primarily about yield for what we were being asked to do.
So do you think that there's greater diversity, and this is for all of you, do you think there's greater diversity in terms of flavour within whisky these days? Or do you think there was, because I think one of the things that I began to notice was there seemed to be a kind of homogenization of flavour to some extent. Everything was beginning to come together, so there was less diversity. But do you think that there's more diversity coming through these days? It could be barley varieties, could be casks, could be...
I'm not old enough in the whiskey industry probably to notice a difference, but I'm very surprised with the request we get to have different things. To me, it's very important because for new oak, but also for used oak. We developed a marketplace for used barrel, and 3 years ago, and there is a lot of demand for very specific things, and no matter the price. And I don't know if you saw that, but and it shows that the barrel really impact the flavor. So I don't know if it covered the flavor of the malt, but for sure it changed the flavor. And there is a lot of demand for even to produce barrel with lemon tree or very strange things sometimes. So yeah, I think yeah, a lot.
I think Hollywood is a prime example of this. I mean, their focus is on the brewing end of the process. I mean, they're using different barley varieties, they're using different malt types, they're using different yeasts. You know, they're not focused on flavour from maturation. So I think, you know, they're a good example of where people are going with different flavours.
Yeah, and yeah, I agree. Yeah. I would say, yeah, we're seeing more when we look across the board new mixed spirits, as we see more, the likes of Holyrood adding in their investigations into diversity. You can see more across the ranges of flavours that we see.
I think it's for me that's hugely important in terms of, you know, the whole thing of building to last. That you have to have that diversity. That, you know, the worst thing that whiskey could do is kind of become homogenized. That you can't really tell the differences in distillery A or distillery B. It's so vital that it does explore all of these other areas, because that is what's going to stimulate interest in the consumer as well. So it's great to see that it's happening. Oh my goodness, we're 20 seconds over. Please put your hands together for a great panel. Thank you. Right, go and taste whiskey.